Guten Abend zusammen.
Hallo zusammen.
Jetzt waren wir Party, wenn wir zu früh sind. Kamera überträgt schon.
Jetzt gedacht.
Hallo zusammen, schönen guten Abend.
Guten Abend.
Jetzt zu hören, Ralf.
Jetzt funktioniert's bestens.
So, guten Abend.
Zwei technische Herausforderungen.
Ach so, Kamera besser aus.
Komm, lass. Setzt euch auf.
Oder? Intro? Ah. So, then, good morning to everyone. Sorry for small delay to technical and mechanical reasons. Just learned that Eckhart is on sick leave today, so Nagapan has to do it alone today. I think it's an interesting topic, testing with AI, not testing of AI. Also interesting topic, but slightly different. This, I think I would hand over to you, Nagapan.
Thank you.
The stage is yours.
Thank you. Hello, one and all. For some of you who don't know about testing and quality services as a practice organization, we do exist within CGI, and that goes with geography. And also, we have special technical areas or competence areas, starting with the test academy, test automation, and I am responsible for AI testing, which is the latest one in the competence area section. So without wasting much time, I move on to the presentation or topic today. Sharpen the saw. So sharpen the saw. entierfvielleicht einer von den 7 Habits of Highly Effective People von Stephen Covey. Und das passt perfekt zu unserer Situation. Wir Testers müssen uns mit KI selbst sharpen. We need to sharpen ourselves before KI das Testen als Skillset unverkaufbar nicht macht. So before KI marks our skillset unsellable, we need to sharp ourselves with the KI. That's the objective of today's session, upskilling testers with KI. Das sind die 5 Themen für heute. Gehen wir sie einfach der Reihe nach durch. A bird's eye view, end, means, and we'll see if the end justifies the means, and about how we are going to reach that, and with a small story at the end. Kai ist nicht neu. Sie ist definitiv älter als wir alle hier im Raum. Aber die Frage ist, was war die erste breakthrough? What was the actual breakthrough? Before ChatGPT war, the Hauptfunktion, the main function von KI war nur zum Prediction. Seit November 2022 erlaubt die Welt einen riesigen Sprung, oder besser gesagt, a giant leap. KI wird creative, or besser gesagt, generative AI, as we all know. So before also the AI existed, when we type the 3rd letter in any prompt, it was able to predict what we are going to type. But now after ChatGPT or the generative AI era, it creates or generates, that's what we call as generative AI. I know, ich weiß, ihr habt wahrscheinlich schon genug Experten gehört, die KI erklären, aber erlaubt mir, ich will euch auch meine Analogie geben, how the KI can be summarized in simple terms. KI is wie ein Vehicle. It's just like an auto or a vehicle. Ein Vehicles main function, ein Vehicle transportiert. Es bringt uns von A nach B. KI macht im Grund das Gleiche. KI hat lange Zeit nur predicted. So far it just one predicted. Aber seit ChatGPT or seit November 22, KI creates or generates. Aber we have different vehicles, so we are verschiedene Vehicles haben, für verschiedene Zwecke, for different purposes, haben wir auch verschiedene Arten von KI für unsere bestimmten Needs. We have need-specific AIs. Not all vehicles are same, not all AIs are same. So AI is an umbrella term covering a garage full of loosely connected technologies. They are built differently, they are used differently, they are used for driving different results. So this happens to be our starting point of the journey, and the journey is also towards ISTQB Zertifizierung. Lass uns mal anschauen, welche Vehicles wir jeden Tag in unserem IT-Bereich fahren. It's clearly confusing. We see a lot of AIs coming up now and then, and the noise is huge. And we are to separate the right signal out of the noise. These tools you might have come across, but how to classify them? We are brauchen nicht jeder Vehicle. We don't need every vehicle, aber nur das, was wir für unsere Zweck passt. We just need what is required for our purpose. Hier gruppen wir die Tools oder unsere KI Vehicles weiter nach ihrem Zweck, what they are meant for. Und jetzt gehen wir noch einen Schritt weiter. Die KI Vehicles sind hier sauber nach dem SDLC Phasen gepackt, sozusagen, im richtigen SDLC Parkhaus. So this explains a little better in the huge spectrum of IT tools where our tool lies. For example, we belong to testing category, and those are the tools very much available in the testing spectrum. So, wir haben die KI-Vehicles kennengelernt und gepackt. Kommt jetzt die Frage, was wollen wir eigentlich mit unserer KI-Testing Practice erreichen? What we want to do? Ganz einfach. Wir müssen ein AI oder KI-Testing Pitch haben. Wir wollen uns als T-shaped Professionals entwickeln. We want to develop ourselves as a T-shaped professionals. Then Einsatz von KI-Tools. We need to augment AI, KI, or AI in every possible tool we use daily. And the Zertifizierung. ISTQB has made our lives easy by providing a clear syllabus or roadmap for certification, and we'll see that. Das sind unsere Draft Objectives, und die schauen wir uns gleich in den nächsten Folien und eins nach dem anderen. So, was ist mit KI-Testing Pitch? Wir als KI-Tester sollten in der Lage sein, den Stakeholders oder Clients klar zu erklären, was wir eigentlich tun, wenn es KI geht. Wir verstehen, was der Unterschied ist zwischen einer traditionellen rule-based normalen Anwendung und einer data-centric oder algorithm-centric KI-Anwendung. Wenn wir dieses Klar-Pitch in Hand haben, können wir mit Confidence, also mit echtem Selbstvertrauen, die Pain Points unserer Kunden adressieren und unsere verfügbare KI-Lösungen verkaufen. We could easily sell when we know what is the difference between the normal AI application and the new school of normal software applications and the new school of AI applications. Und das Pitch muss nicht immer simpel sein. Manchmal brauchen wir ein umfangreiches Extensive oder professionelle Wording, vor allem wenn wir mit Kunden oder Führungskräften sprechen, die den Mehrwert von KI-Testing wirklich verstehen wollen. The elevated pitch we can see, we can tailor and we can use depending on the need before us. Hier geht es unser Profil als Tester. Wir sprechen von T-shaped Professionals. Das bedeutet, wir haben tiefe Expertise im Software-Testen. Wir haben das schon, also unser Daily Business. Und gleichzeitig bauen wir breites Wissen in KI-Engineering auf. Damit das von intelligenten, futuristischen Systemen wirklich verstehen können. In dieser neuen Rolle als KI-Tester, unser Ziel ist nicht nur, dass Software ohne Bugs oder Fehler funktioniert, sondern dass neue Smart-Systeme verantwortungsvoll oder zuverlässig, zum Beispiel with responsible and we just handle. So, KI Argumentation in Testing Tools. Das ist ein Bereich, das ist ständig entwickelt, sozusagen Work in Progress oder Work immer in Progress. Wichtig für uns als Practice ist, dass wir die neuen Features in Traditional Testing Tools im Blick behalten, je nach Bedarf, je nach Verfügbarkeit ausprobieren und unsere Erfahrung untereinander teilen. So bleiben wir alle up to date. Jetzt kommen wir zur Timeline der KI-Testing Practice. Hier seht ihr, was wir bisher schon gemacht haben, welche Aktivitäten gerade laufen und was wir für die Zukunft geplant haben. Und dann ein kleiner Sneak Peek auf die KI, ISTQB KI Zertifizierung. So, im November Jahr 2023 haben wir rund 8 Partner das ISTQB KI Training bei Imbus besucht. Im gleichen Monat haben wir offiziell die KI-Testing Practice gestartet. Christian Holper im Dezember 23 hat Christian Holper die Zertifizierung erfolgreich geschafft und im Februar 24 war ich selbst dran. Danach habe ich die Masterclass gestartet, eine zweistündige Vorbereitungssession für ISTQB KI-Zertifizierung. Und es läuft seitdem regelmäßig für unsere Partner weiter. Bis heute, inklusive Kiran, Enrico und die latest Miraj, sind wir schon auf 5 zertifizierte KI-Tester in unserer Practice. Außerdem machen wir Keynote-Sessions, da teilen unsere Kollegen, die KI-Experten sind, ihre Erfahrungen zum Thema KI-Testing. Dazu habe ich gleich ein paar Slides vorbereitet. Schauen wir uns das gleich in der nächsten Slides an. Parallel laufen auch die On-Demand-Trainings und als nächstes planen wir einen 2-Days Vorrat-Workshop hier in Eschborn. Und hier steckt ein Beispiel aus einer unserer Keynote-Sessions. Das ist die Einladung und die Infos dazu. Das ist von Testing Bus bei Manfred. Die ID hier, die ID hinter den Keynotes ist ganz simpel. Unsere Partner, die schon KI-Expertise haben, teilen ihre Wissen und ihre Erfahrung rund um KI-Testing. So schaffen wir eine Plattform, wo alle voreinander lernen können, direkt aus der Praxis und für die Praxis. Success Stories teilen wir, damit noch mehrere Kollegen Lust auf die Zertifizierung bekommen. Das ist unser Masterclass Flyer, 2 Stunden kompaktes Training zur KI, ISTQB KI Zertifizierung. Es hat Learning Objectives, Agenda und Format. Und jetzt kommen wir zum eigentlich Hauptpart. Ein kleiner Sneak Peek auf die ISTQB KI-Zertifizierung. Und ich habe meine Zertifizierung auf Englisch gemacht. Darum erlaube ich mir, den technischen Teil gleich auf Englisch zu erklären. Danach switchen wir wieder zurück ins Deutsch. So, this is the roadmap, what ISTQB has already clarified as path we need to take when it comes to AI testing. So the first quadrant, what you see is just the introduction of AI, what it is, and what are the new quality characteristics. And as we see the vehicle right side, every vehicle is different, but the engineering has something to do in common. And what is that engineering? That is what we are going to see as a main part of the theme. That's machine learns or machine learning. Machine learns with data, and these data is of 2 types, labeled data and unlabeled data. When the machine is learning through labeled data, we say that as supervised learning because the data is labeled. And 2 types of labeling. Supervised learning is there, that's classification and regression. We could classify a thing based on past data, or we can predict a continuous value, that is regression. And it is also possible to establish relationships between data, clustering. For example, identify a patient type or customer type, or associate between data. A person who buys a car also buys an insurance. That's an association. So we have unsupervised learning based on data. And machine also learns from environment regressively. So, for example, an automatic car which runs in the same route every day, it learns something new. That's called reinforced learning. So, the machine learns from the environment also. In this we have now three categories of learning: supervised learning, unsupervised learning, and reinforced learning. Those are the three major kinds of machine learning algorithms. To say simply, that's the engine of any vehicle, what we have seen so far. So now we have machine learning algorithms, machine learning data, and machine learning model development is the thing what any application or product or name it companies they do is nothing but machine learning model development. So when we say we are doing something on AI, it's nothing but data and machine learning. So machine has learned how to do the Osberto. How do we assess that? We have some ratios, how accurate the machine predicts the required answer, how accurately it classifies. If the machine classifies 50% correct and 50% false, then it is almost useless. So we need to go for a ratio, that's accuracy. And it has predicted correctly and how confident it is. We are so bothered about the prediction ratio. How precise is it? So in the second example, the objective is to predict the cancer cases, real cancer cases. So we can't afford to miss the real cancer case. So how precise we are predicting? There is a ratio that's called precision. And we are also bothered about predicting the non-real cancer cases. So that's sensitivity, one more ratio. And when we are bothered about both equally, for example, the fourth use case, we are feeding food for an animal in the zoo. So when it is a monkey and it is not a tiger, we should feed the right food. So feeding it either way will be faulty. So in this case, we take a balanced score that's called F1 score. That's also a way to measure the machine learning algorithm. So to summarize, these are all something new for a conventional tester who has just taken data, analyzed, and created test cases, executed functional test cases involved in automation. So this is a new area the conventional tester has no idea about. So ISGQB has clearly classifies this and equips us to be ready for the upcoming challenges in the AI domain. And a slight overview about neural networks, deep neural networks, what a neural network is, and how the neural network propagates layer by data results and achieves the result at the end. That way, the neural network, introduction to neural network. And then, in my opinion, the crux of tester to transform himself into an AI tester is understanding the nature and challenges involved in the AI application, what we are going to see in the near future. So the AI applications, we all know they are data-centric applications, and it revolves around data and algorithm, and they are prone to attacks. So ISGQB is giving an insight on what are those kind of attacks. And the first one is adversarial attacks, where an unwanted party supplies some invalid data to make the algorithm lose its track, to classify falsely or to predict wrongly. So this is one challenge what a tester should know before testing. I mean, should anticipate while testing an AI application. And data poisoning, malicious data or can be entered into the training phase or testing phase, and that could make the algorithm kaput. So we should be testers, we should be aware of that. That's explained. And high performance combinations. So when we test a data-centric application, most of the unfavorable outcomes are due to some minor combinations. When two data points interact, when two minor data points interact, they have these kind of unexpected results or unexpected expectations. So those have to be identified and tested appropriately. So in the next slide, we'll see the techniques how to test that. But here we need to acknowledge that such risk is there and we need to address them. High performance parameter combinations, identify them and test them. So here is an example how an autonomous vehicle, what are the possibilities for an autonomous vehicle to collide when it is pulling over. So here the challenge is to identify the right points where the chances of a collision is really more. And third, what the traditional tester so far had not experienced is the test oracle problem, the problem of expected result. So the expected result so far was very finite. Either the loan is accepted or rejected, either a test case passed for a specific data range or not. But now the expected result is evolving. Here the challenge keeps evolving. For example, in this area, in this situation, it could be like, what is the cost of the apple? So mere identification is one step or the step one, and after that it evolves because we have a lot of varieties. Do we stop there? No, it goes further because of the quality of stock. Do we stop there? No, further. Time of sale. And these are the 4 parameters what we have seen, and it may evolve more. And this is also a kind of a definitive boundary. But when it comes to complex applications like stock market share trading or autonomous vehicle driving, the possibilities are even more. And functional performance. We have the conventional tester might have developed or tested an application with one specific objective and one specific application domain. But the situation may not be the same in the coming days, because for one example or for one objective, different kinds of algorithms could be possible. For the same set of data, different kinds of algorithms are possible, different kinds of trainings are possible. So here what we see is a matrix of 5 algorithms and different evaluation criteria, what we have seen before. And we may end up in testing end-to-end or all cases, and we need to check what ratio is crucial for us, and by that we can decide what is the right algorithm or what is the right training or model what we have, what we can propose or check as passed. So this is one example, and it is not always a simple number easy to calculate. There are some complex performance metrics also where we need to analyze the result based on a 2D or a 3D in a graphical plane or dimension. And bias, this is something what we have not seen. We traditional testers have not seen so far. And we need to check if the data with which the application developed is without bias, or if there is a bias, and what kind of bias is it and how to mitigate that. These are some new challenges what the traditional tester, when he is moving towards an AI tester, should foresee and equip himself. So this is data bias. And another example is algorithmic bias, where the parameter itself is skewed. For example, here we have an hypothetical example where the application is to grant credit. To grant credit, if credit score, income, employment status, net worth, if all these are taken, that's a valid parameter. But if some weightage or any weightage is given to body mass index, then that's not a valid parameter. So the algorithm itself is skewed, and we say that as algorithmic bias. This is what automation bias is, another kind of bias where the system drives us to take its own decision. So we need to check, a person, the favoring recommendations of the system should also be here we say a human in loop. The recommendation should not always be taken for granted. So a human in loop should be there, automation bias. And complex specifications. So far, we had not seen such. We traditional testers have experienced only simple specifications. Specification document or use requirements document will be there. That will be translated into user stories, and user from there we take that as a test basis, and we decide the test cases, or we generate the test cases. But now the specification challenges are into the qualitative domain. From the quantitative domain, it is moving into qualitative domains, and all the parameters what we see here are qualitative, exploratory. So to explore potential disease outbreaks, we can't quantify that easily. It's qualitative. So it is evolving. It is expected to improve. What is a degree? And the challenges could be probabilistic. They may say a ratio, but where is the standard, or the standard could keep evolving. For example, 85% is a valid ratio today, but after 2 or 3 years, it may not be. So it is evolving. And it could be ambiguous also, replicating human behavior. So even when a human does a task, there could be some variations. So ambiguous. Autonomy and flexibility, these are also some quality characteristics of the AI application which is developed. To say simply, they are complex. The specifications are complex. And given these challenges, ISTQB has proposed or recommending few testing techniques to address the challenges. Adversarial testing, data poisoning, pairwise testing, A/B testing, back-to-back testing, MT, that is metamorphic testing, experience-based testing. These are the testing strategies what ISTQB is proposing to test the AI applications. To explain every strategy is beyond the scope of today's presentation. This I conduct in my masterclass. So to say one example, metamorphic testing is a relationship-based testing where when we have a test oracle problem, we take a relation and we anticipate the expected outcomes. For example, if a person earning between 10,000 and 20,000 is buying a specific car of a specific price, a person earning 20,000 to 40,000 may buy a car with a price which is above the one which we said before. So a relationship is established, metamorphic relationship, and based on that, the data is given. So these challenges are addressed. These challenges are addressed based fully or partially based on this testing strategies. And something new, what it comes to test environment is the AI application has some intrinsic qualities like self-learning, multi-agency. For example, they interact with the different systems, multi-agency, a different hardware. Of course, we as software testers may not be involved in the much in the hardware configuration, but hardware autonomy, big data, these are all some new challenges what an AI tester will be facing. And virtual environments are present, and mostly virtual environments are targeted when we test an AI application because of the obvious scenarios like dangerous scenarios, unusual scenarios, extreme situations, and time-intensive situations. So they come with some benefits like observable, they are always controllable, replicable, and available. And ISGB has shown us some industry examples also. For example, this is one modular robot simulation engine for testing the industrial robots. And habitat fear, this is one environment given by Facebook for testing human avatars and robots. And NVIDIA, needless to say, they have come out with some driving consolation hardware where the automation course software is tested in a virtual environment. And finally, MATLAB simulation. So when we are doing some scientific computations or simulations, we use this as a virtual test environment. These are some representative environments recommended by ISGPB. And finally, the most interesting part is how we are going to use AI for testing. So we have AI now and how we are going to use that for testing, how AI could assist us in testing. So these are the AI technologies, what we see from fuzzy logic to ML techniques. And ISGUB has given precisely 5 areas where AI can strongly support us in our conventional testing. That is, first one, analyze defect reports earlier and defect triage. Earlier, the test manager or the defect manager, he used to do the defect triage by his virtue of his experience or presence in the project. But now AI can rely on metadata and other stuff to do the bug triage easily and effectively. These are the technologies used in that analyzing defect reports. And next one is AI generated test cases. We have one product, testing boss is also the whole name of testing boss was GenAI, and we use generative AI to create test cases. This is a straightforward usage. And AI optimizes regression test suites. For example, every software feature, every software module or feature is in the form of a user story or a software artifact, and in turn, they form into 2 or more user stories, form into use cases, a workflow, or whatever we say as a usage construct. And these are tested by 1 or 2 test cases. A test case can cover 1 or 2 paths in that workflow, and coverage matrix is derived, and coverage matrix comes with recent code changes, associated defects, and past results. And with that, we can optimize the regression test suites. So to say simply, we have ample data and AI will act on that ample data. And earlier, an experienced tester was required to do the regression test suite optimization. Now AI can do that.
May I ask?
Yeah.
So there are tools which are creating regression test cases based on the current test cases and the fixes we need to do in the software. Did I get it right?
Yes, yes. And also, if we have a new release, some candidate test cases out of 1,000 or 2,000 test cases has to be selected so that the new release goes without any issues. So which are the candidate test cases that should be executed? Earlier, only an experienced tester can do that. But now, based on the new software code, the AI will analyze the software code and pick the right test cases. So as in,
Can you share some tools afterwards with me who should do that? That would be great.
sure. I should work on that, but definitely that's an area of interest for me. We are doing. So AI defect prediction, this is also a straightforward concept. We had earlier, the code is kept inside the repository. So when we say a software, it is nothing but a software, and any or a huge software can be broken into software artifacts. Either it should lie as a package, classes, or files. So these artifacts come with lot of metrics. For example, code metrics, line of code, who has done it, code coverage, everything. I mean, people metrics, like the team experience, who has done it, workaround, organizational size, all those. And process metrics, when it was developed, number of commits, test, those tests conducted, all those process metrics. And based on these metrics, we can classify a package on or an artifact as a bug free or a buggy. So every package or an artifact present in a software artifactory can be classified as a buggy or a error-free software package. If black and white, we can say 50 with a percentage, with a probability. Package 1, 90% bug free. So some way now this resembles a labeled data, and when we have a labeled data on any software artifact or collection, we can create a defect prediction model, which means we are taking an algorithm, training this labeled data, and we are coming out with a defect prediction model. And with the defect prediction model, we can we can predict the upcoming or new software package based on the old data. So for that, we use the following technologies. And the last, AI improves GUI testing by enhancing the object identification. For example, earlier we used to have the testing tools or test automation tools where the objects are identified based on static parameters like XPath or IDs or whatnot. They keeps changing time to time for any season. And to say simply, that's very brittle. And with the new AI-driven object identification, it is not always the static variables, but they use the historically stable elements and also the relationship between each other. And they predict the object identification in the new automation tools happen based on supervised learning, and they are quite stable, robust, adaptive, and here comes the term self-healing. And that is when something is broken, it heals on its own. That's self-healing. So it is not just for the software code. So it is also for we, the testers. When we are robust, adaptive, and self-healing, we can also be leaders. So what is the hot start on West Deutschland? So this is a small story which I have prepared. Please bear with me. So I switch back to Deutsch. So, vor etwa 10 Jahren kam ein guter, ausgebildeter Ingenieur aus Deutschland nach Deutschland, um sich bei einer bekannten deutschen IT-Firma vorzustellen. Das technische Interview lief super, hat es bestanden. Dann, nach dem technischen Teil, wollte sein Chef noch ein bisschen allgemein Wissen über Deutschland testen. Fragte so: Weißt du, was die Hauptstadt von Deutschland ist? Der Kandidat sagt Berlin. Richtig, aber das war sehr einfach. Jetzt mal eine schwierigere Frage. Was war die Hauptstadt von Westdeutschland zur Zeit der Beteiligung? Der Kandidat sagt Düsseldorf. Hat den Job bekommen. Auch wenn die Antwort falsch war. Die richtige Antwort ist Bonn. Nach genau 6 Monaten, also der Kandidat die Probezeit erfolgreich abgeschlossen hatte, wurde ihm klar, die Hauptstadt war eigentlich Bonn. Also fragte er seinen Chef, der ihn eingestellt hatte: Hey Markus.
An insider?
Der Chef, okay. Herr Manager, ich habe damals Falsches gesagt und du hast mich trotzdem eingestellt. Wieso? Dein Chef sagte, an diesem Tag habe ich 3 Kandidaten interviewt und allen dieselbe Frage gestellt. Alle haben eine Stadt als Antwort genannt. Deine Antwort Düsseldorf war definitiv nicht richtig, aber Düsseldorf war am nächsten dran anbauen. Sozusagen der nearest correct answer. Und genau funktioniert. Und genauso funktioniert KI. Es gibt dir nicht immer die perfekte Antwort, aber oft die statistically am nächsten dran ist. So, wenn es um KI-Testing geht, I am your nearest correct answer.
Gibt es Fragen?
Gibt es Fragen?
Die Folien werden noch verteilt.
Ja, ich kann.
Sehr schön. Ich habe eine Frage. Würdest du sagen, mit KI ist es einfacher, ins Testing einzusteigen? So wie man hat ein richtiges Tool, was man direkt nutzen kann und man ist einfacher im Thema drin? Oder ist KI eine andere, also noch ein Layer on top, was man noch extra lernen muss und man muss trotzdem von Anfang an Testing erstmal normal lernen?
Beides. Es ist, wir sind ganz in die Beginning, Anfangsstufe. Meiner Meinung nach ist, es wird immer besser. Es ist so früh, so etwas ist konkret zu sagen. Ja.
Okay.
Aber es ist immer gut, die Basics selbst zu verstehen, damit man beurteilen kann, was da rauskommt.
Ja.
Darf ich auch noch eine Antwort auf diese Frage geben? Oder? Also, ich benutze privat ziemlich viel KIs und auch schon relativ lange. Ich glaube sogar schon, bevor es den Hype dazu gab. Und ich würde sagen, eine KI kann extrem hilfreich sein, wenn man ihr nicht vertraut. Also man muss sich halt darüber im Klaren sein, was eine Halluzination ist. Das sollte man wirklich verstehen, wenn man intensiv damit arbeitet. Das heißt, die können halt einfach extrem plausibel belügen, sodass man möglicherweise auch erstmal einige Zeit braucht, um herauszufinden, ob es wirklich stimmt. Das kommt aber auf die Fragen an. Aber besonders, um deine Frage zu beantworten, wenn es um edukative Sachen geht, also wenn du in ein neues Thema neu einsteigen möchtest, finde ich, sind KIs extrem hilfreich, dir Literaturhinweise zu geben, dir ja quasi einen Überblick zu geben, wo du Einstiege findest und so weiter. Und auch beim Arbeiten ist es hilfreich. Du musst ja immer nur darüber im Klaren sein. Im Endeffekt ist das ähnlich wie beim Menschen. Eine KI sagt dir vielleicht etwas, was nicht stimmt, und das musst du immer so ein bisschen überprüfen. Ja, besonders dann, wenn es, weiß ich nicht, ich hatte letztens mal das Thema mit einer Kollegin, wenn du irgendwie zum Beispiel in die Buchhaltung gehst und du vertraust einfach blind auf Formeln, die eine KI generiert hat, dann kann das halt sein, dass du nachher eine komplett falsche Bilanz hast oder vielleicht sogar wegen Betrugs angezeigt wirst oder irgendwie sowas, ja. Aber also der Kern meiner Aussage ist, vertraue nicht einfach hundertprozentig darauf, was sie sagt, aber es ist extrem hilfreich, um viel, viel schneller, also ich würde sagen, du kommst bestimmt 80-90% schneller in ein Thema rein als ohne KI. Wobei die KI hier nur einen Menschen ersetzt, der mit dem Thema vertraut ist. Aber das brauchst du dann quasi nicht mehr. Dabei kann die KI wirklich extrem helfen.
Okay, danke.
Noch Fragen, Anmerkungen? Sich noch ein Nein an, würde ich sagen, vielen Dank und schon Feierabend.
Vielen Dank.